Algebra 2, Topic 3, Polynomial Functions. In this new topic, we have 7 lessons, just like Topic 2, but we will talk about polynomial functions. So the big topic essential question is, what can the rule for polynomial function reveal about its graph, and what can the graphs of polynomial functions reveal about the solutions of polynomial equations? So again, this whole topic is all about polynomial functions, so we'll really dive into what polynomial functions are, what the key characteristics are, if they have any properties that are special, and we'll look at their equations and functions and how we can apply them in real life. So we do have a lot of topic vocabularies here: binomial theorem, degree polynomial, and behavior, even function, identity, leading coefficient, multiplicity of a zero, out function, Pascal's triangle, polynomial function, relative maximum, relative minimum, rational root theorem, remainder theorem, standard form of a polynomial, synthetic division, turning point. So it will be helpful if you could review these vocabularies beforehand, so that as we go through our lessons, you know just a little bit of an idea what we are going to be talking about. But even if you don't understand right now, that's fine, because we're going to go through them. Okay, so yeah, we have some mathematical modeling in 3 acts and STEM problems that you could do. Let's start with the very first lesson, 3-1, graphing polynomial functions. And obviously this is an introductory lesson, so there are going to be a lot of concepts and vocabulary that would be introduced. Okay, so in this lesson, we'll be able to predict behavior of polynomial functions. Let's start with explore and reason. Consider functions of the form f of x is equal to x to the power of n, where n is a positive integer. So we already know what exponents are. We know quadratics. What if n is a positive integer where it's bigger than 2, right? Because it's possible, it's very possible. So if y is equal to x when n is 1, it's just a linear line, right? Equation. And then when x is squared, then we know it's a quadratic function like that. If x is cubed, if you look at this graph, it's the blue line over here, it's a blue curve. It has a little bit of a twist, right? One arrow going up, the other arrow going down. But x to the 5th power also looks very similar, just slightly different in this graph. Okay, so if you graph these for n is equal to 1, 3, and 5, and you look at this graphs in just quadrant 1. Quadrant 1 is the positive quadrant for both x and y. So this is Q1. Yeah, so as the exponent increases, what is happening to the graphs? So this is 1. We know that 2 is going to be like that. But when n is equal to 3, we have a blue line over here like this, and then a green line over here, right? As it increases, you see that it's getting a little bit steeper and steeper, right? Yeah. And which quadrants do the graphs pass through? We see the graphs in quadrant 1 and quadrant 3. And so when we look at the odd numbers for n, these are some behaviors that we see in polynomial functions for odd numbers, right? So let's write that somewhere. I'm gonna type on top right here. Okay, so let's say a. As the exponent increases, the graph becomes steeper. And in which quadrants? The graphs pass through quadrants 1 and 3. Right? So you count the quadrants from the top right to the left, it's counterclockwise. Okay, 2, 3, 4. So now graph f of x is equal to x to the nth power for n is equal to 2, 4, and 6. What happens to these graphs in quadrant 1 as the exponent increases? So when you graph them in a graphing calculator or technology, what would you see, right? So we know the quadratic function is going to look like that. And then if it's x to the 4th power, when x is 1, right? Then y is going to be 1 as well. When x is 2, this is supposedly 4, okay, for x squared. But then when x is 4th, 2 to the 4th power would be 8, right? So then we have a steeper curve. And then when x is to the 6th power, it goes even steeper like that. Yeah. So this would be x to the 4th, x to the 6th. So you'll see the graphs getting steeper and steeper as well, but the quadrants are different, right? Do you know why? Because when the x is negative, your y would still be positive because you have a power of even numbers, right? So you'll always have a positive number. Okay, let's record that and see and write down the relationships. So as the exponent increases, the graph also becomes steeper. And the quadrants are, the graphs pass quadrants 1 and 3. 1 and 2, sorry. Yeah. And now we're going to write two equations in the form f of x is equal to x to the power of nth power with graphs that you predict are in quadrants 1 and 2. So obviously not the odd numbered ones, but the even numbered ones, right? And you can use graphing technology to test your predictions. But you already know that it's going to be even numbers if you want it to be in quadrants 1 and 2, right? If it's in quadrants 1 and 3, you know it's going to be odd numbers. So for the first question, quadrants 1 and 2, you can have any functions that are in powers of even numbers. So you can do 6th, power of 6th, or you can do x to the power of 8th or 10th. Okay, any even numbers would work. For quadrants 1 and 3, you would have even or odd numbers, right? So anything that has a power of odd number would work. 9 or 11, okay, any odd numbers. All right, so these are some characteristics of polynomial functions that we have already noticed. So we're gonna think about the lesson essential question: how do the key features of a polynomial function help you sketch its graph? Let's continue with example 1 in the next video.